Example on operator equation. So our first example is let D is a mapping of all continuous function in interval 0 to 2 pi to 0 to 2 pi be the differential operator. Solve the operator equation df of x is equal to sin x. Now solution. Here we have mapping D is the differential operator. Now we have to solve the operator equation. And which is operator equation? df of x is equal to sin x. Now first we will recall all the steps. What are the steps to solve any operator equation? So we have 3 steps. First of all, we will find associated homogeneous equation. Then we will find the solution of nullity of T. Then we will find solution for non-homogeneous equation. So these are the 3 steps to solve any operator equation. So we have d of f of x is equal to sin x. And first we will try to find its homogeneous solution. Now we consider the associated homogeneous equation df is equal to 0. Then we know what are the function whose first derivative is 0. So that are nothing but constant function, because first derivative of all the constant function is 0. So we can conclude this f is nothing but our constant function. So the solution set of this equation is the set of all constant function. That is, our k is nothing but all function such that fx is equal to b for all x belongs to 0 to 2 pi and our b is constant. So we have find here our homogeneous equation solution. Now to find non-homogeneous equation solution, so see, d of f of x is equal to sin x. That means if I have to find non-homogeneous equation solution, now d of f of x is equal to sin x. What was our fx? So it's the first derivative is sin x. So we know if our fx is minus cos x, then we will get its first derivative as sin x. See, therefore one solution of d of f of x is equal to sin x is the function f naught. We are giving name this as f naught, where f naught is nothing but where f naught is of x is equal to minus cos x. So if we are considering this is our f naught which satisfy the given equation, then we will try to prove it that it's correct. So let or since d of f naught of x is equal to d of minus cos x, that is derivative of minus cos x, which is equal to minus as it is, and derivative of cos x is nothing but minus of sin x, which is equal to sin x. Therefore, if I am taking f naught as minus cos x, then it's hold our equation, because if we are considering f naught fx is equal to minus cos x, then its derivative is nothing but sin x. So we can say that f naught x is our one particular solution. Therefore, the solution set is f naught plus this k. In other words, we can say that the set of all functions g where gx is f naught, that is minus cos x, and k is a constant, is the solution set of df of x is equal to sin x. So this was how we can solve any question related to operator equation. Now to understand it more clearly, we will try to solve one more question. So our next question is example, let T is a mapping from V5 to V3 be a linear defined by T of E1 is equal to 1 by 2 F1, T of E2 is equal to 1 by 2 F1, T of E3 is equal to F2, T of E4 is equal to F2, and T of E5 is theta V3, where E1, E2, E3, E4, E5 is the standard basis for V5, and F1, F2, F3 is the standard basis for V3. Then solve the operator equation. T of u is equal to 1, 1, 0. Now solution. Before starting its solution, let us first understand what is given the question. So T is the mapping from V5 to V3. V5 has standard basis as E1, E2, E3 and E4, E5, and F1, F2, F3 are the standard basis of V3. T of E1 is defined as 1 by 2 F1, T of E2 is defined as 1 by 2 F1, T of E3 is defined as F2, T of E4 is defined as F2, and T of E5 is defined as theta V3. Theta V3 is nothing but 0 element in V3. So from here you can see our T is not defined in correct way because it is written in the basis form. So T of E1 is F1, but we have not given question in such a way that T of U is equal to some V naught. So first of all we will try to write our T. So first we will write what is given in the question. So T is mapping from V5 to V3. Here E1, E2, E3, E4, E5 and F1, F2, F3 are standard bases of V5 and V3 respectively. Now for any U is equal to x1, x2, x3, x4, x5 belongs to V5, we can write U is equal to x1, x2, x3, x4, x5 is equal to x1 e1, x2 e2 plus x3 e3 plus x4 e4 plus x5 e5. I can write this because our V5 is a vector space. So this element can be written as a linear combination of element in standard. So this can be written as linear combination of this. So E1, E2, E3 are our bases. So this can be written in linear combination of elements of bases. Now here if I take T image both the sides, then T of U is equal to, since here my T is linear, so I can write T of x1 e1 plus T of x2 e2 plus T of x3 e3 plus T of x4 e4 plus T of x5 e5, which is equal to, since it is linear, so it can be written in the scalar multiplication form. So x1 outside T of e1 plus x2 T of e2 plus x3 T of e3 plus x4 T of e4 plus x5 T of e5. Now here T1 is nothing but 1 by 2 F1, T2 is nothing but 1 by 2 F1, T3 is nothing but F2 and T4 is nothing but again F2 and T5 is 0 3. So from this, if I write in terms of F1, F2 and F3, then we have x1 by 2 plus x2 by 2 F1, x3 plus x4 F2, and here I can write 0 F3 since my standard bases are F1, F2, F3 for V3. Now from this, if this is the linear combination of F1, F2, F3, so I can write this as x1 plus x2 divided by 2, x3 plus x4 and 0. So my T of x1, x2, x3, x4, x5 is nothing but x1 plus x2 upon 2, x3 plus x4 and 0. Now I have my function, how it is actually defined as I have find. So we will try to solve our question. So first, therefore the associated homogeneous equation equation is T of x1, x2, x3, x4, x5 is equal to theta v3, which is nothing but x1 plus x2 divided by 2, x3 plus x4, 0 is equal to 0, 0, 0. Now this is equal to x1 plus x2 divided by 2 is equal to 0 and x3 plus x4 is equal to 0. This implies x1 plus x2 is equal to 0 or x1 is equal to minus x2. Here my x3 is equal to minus x4. Now we have to find nullity of T. Therefore nullity of T is equal to x1, x2, x3, x4, x5 belongs to V5 with x1 is equal to minus x2 and x3 is equal to minus x4. So here x1 is equal to minus x2, so I will replace one by another. So if I take x1 as x1 only and x2 by minus x1, x3 is equal to x3 and x4 by minus x3 and x5 as it is. This all belongs to V5. Again, I can write this in the linear combination of some elements. So if I can write this for x1, this is 1, minus 1, 0, 0 and 0. For x3 plus x3, 0, 0, 1, minus 1, 0. And for x5, 0, 0, 0, 0 and 1. Where this x1, x3 and x5 belongs to R. These are any three real numbers. So from here we can see this element can be written in the linear combination of these three elements. That means that nullity of T contains 1, minus 1, 0, 0, 0, 0, 0, 1, minus 1, 0 and 0, 0, 0, 0, 1. This is my nullity of T. Now we have to find one particular solution for the given operator equation. To find a particular solution, here V0 is 1, 1, 0. Then and see, first of all we will see that this belongs to range of T or not. So it is clear that this belongs to range of T, because if I will put 1 here, then it is x1 is equal to 1 minus x2 and x3 is equal to 1 minus x4. So obviously this belongs to range of T. Then non-homogeneous equation, that is T of u is equal to 1, 1, 0. Now T of u is nothing but x1 plus x2 divided by 2. This is x3 plus x4 and this is 0. This is equal to 1, 1, 0. So from here x1 plus x2, on comparing both the side, I will get here 1 and 1 into 2 is nothing but 2. My second equation x3 plus x4 is equal to 1 and 0 remain as it is. From this I can say that x1 is nothing but 2 minus x2, and from here I can say that x3 is 1 minus x4. See, from here we can conclude that if I change my x2, then x1 will change. If I change x4, then x3 will change. That means this x1 and x3 are depends on x2 and x4. So what is the solution of this equation? It has one or two solution, or it has infinite solution? So obviously it has infinite solution, because my x2 and x4 are not restricted. It can be 1, 2, 3, 4 or any value. So x3 and x4 has infinite value. Then my x1 and x3 has also infinite value. So for this question, our solution for non-homogeneous equation is infinite solution. So it is not possible to write all solutions, so we will write only one particular solution. So how to find that? Here we have a lots of choice for x2 and x4. So there is a one way through which everyone's answer can be same. See, you can choose x2 is equal to 1, x4 is equal to 0, x2 is equal to 2, 3, 4 or any value. Similarly for x4, so better we always select first one as 0, first one as 1 or second one as 0, or either first one is equal to 0 or second one is equal to 1. So our answer will remain same. So see, if I choose putting x2 is equal to 1 and x4 is equal to 0, so I have to select one particular solution, therefore I am selecting this. Always we will try to select this kind of value, so everyone answer is be equal. So from here, if x2 is equal to 1, then x1 is equal to 2 minus 1, that is 1, and x4 is equal to 0, and then x3 is equal to 1 minus 0 is 1. So x1 is equal to 1 and x3 is equal to 1. Now our one particular solution is, therefore one particular solution is x1, x2, x3, x4 and also x5 is equal to 0, x5 is equal to 1, 1, 1, 0, 0. Therefore, the complete solution of the equation, which was t of u is equal to 1, 1, 0, is the linear variety 1, 1, 1, 0, 0 plus nullity of t, that is the set of 1, 1, 1, 0, 0 plus nullity of t. We have a minus a, b minus b, c, where this a, b, c belongs to real numbers. This can be written as a plus 1 minus a plus 1, b plus 1 minus b, c, where ABC again belongs to R. In other word, this is the T pre-image of our given T of U 110. So, in other word, the T pre-image of 110 is the linear variety. So here we solve one more question for operator equation. Now from this question we can conclude one thing. See, we had seen that our nullity of T was not trivial solution, it has non-trivial solution. That means other than 0 element, we have element whose T image is 0. If nullity of T has non-trivial solution, then we are getting non-homogeneous equation has infinite solutions. So from here we have to remember one thing, that if T of U is equal to not equal to theta v, then non-homogeneous equation has infinite solution. So we have to always remember this. If nullity has not zero solution, then non-homogeneous equation has infinite solution. Where it is used, we will see in our next class.